Okay, so let's pick up where we left off with last time. And we were talking about the polarity of these bonds here. So remember the difference then between the electronegativity between the two atoms, if that difference then, sorry, hold on a second. If the difference then between the electronegativity differences between the two bonds are between the two atoms are zero, okay, and we have then a nonpolar covalent bond. If that difference then is, and this is a number that's kind of just roughly about 0.3, this is the number that we've kind of chosen to mark the difference between a nonpolar bond and a polar covalent bond. So if the difference in between the two atoms then is 0.3 or greater, then we can say that the bond is going to be polar in nature. The larger the difference here then, the greater the polarity of the bond is going to be, so that when we get to a polarity difference and electronegativity difference that is greater than roughly 2, then we can call that bond then an ionic bond. You can think of an ionic bond, like we said then, as an extremely polar bond. Okay, so we take a look at an example of these here. So let's go ahead and work out this problem together. So we have then take a couple of minutes to take a look at this and work through this and see what you get. Describe the differences in electronegativity between these bonds here and put them in order from most to least. Okay, so I'm going to pause here, give you a moment then to answer the question. Make sure you write down your answers, and then I will give you the answers afterwards, and make sure that you write down my answer as well. And then you will post these this particular problem, you'll post it to Classroom, and that way then you'll get credit for classwork today. Okay, so go ahead, take a couple minutes, work through this problem. Okay, let's go ahead then and let's work. Let's see how the polarities here are different. First of all, we don't have any axes, so you're not given any numbers. You're not given any differences in electronegativities, and so what we can do then is we can take a look at how far these atoms are from each other on the periodic table. And remember, with the periodic table, the electronegativity increases as you go up the group and towards the right across a row period. And so with that said, we noticed then with the first 3 bonds in A, fluorine's all the same. And so we have to check then on the periodic table how far each one of these atoms are from the fluorine. So with that said then, oxygen is closest to fluorine. So we expect then that bond to be the least polar. So as we go through, we get further away. Nitrogen and fluorine then would be the next most electronegative, and then finally carbon and fluorine are furthest away. So the carbon fluorine bond would be the most electronegative of those bonds. Now down here then we notice then that the atoms are not all the same. We have then silicon attached to fluorine here, carbon attached to fluorine here, and then nitrogen and oxygen here. These two are very close together, so we expect again that the electronegativity of those two should be fairly small compared to the other ones. Again, since we don't have any numbers, this is kind of just for us an estimate. Okay? And then with this, then silicon is further away than fluorine than carbon is, so we expect then the carbon fluorine would be the next, and silicon fluorine would be the most electronegative in that order. Okay? So make sure you write this down and then post it. All right. This is chlorine. Chlorine, we expect then that to be a nonpolar bond, so we can go ahead and write that down as being the least polar. And again, then we go back then to see which one's furthest away. Boron is furthest away from chlorine, and so therefore sulfur chlorine should be the next most electronegative, and then with boron and chlorine be the most electronegative of those bonds. Okay? All right. So there are the answers there. So we got carbon, fluorine, nitrogen, fluorine, oxygen, fluorine. We got silicon, fluorine, carbon, fluorine, nitrogen, oxygen. And there's the last set of answers. Okay, so please make sure you write those answers down on your paper. And then at the end of this period, then make sure you upload your work to Classroom. All right, moving on then. Let's take a look at number 2 here in your problem set. And I want you to, again, take a couple of minutes to write down your answer. Okay, and then I'm going to share with you the actual answers. And then make sure you write down the answers that I give you and your work as well. And then again, post that as well. Okay. All right, so we're going to do the same thing here. We want to find then least to polar and still be considered polar. So first one here, we notice in that bond has to be, this is going to be an ionic bond. How do we know that? We have a metal and a non-metal together. Okay, so we have that one be excluded because that would not be considered a polar a covalent bond. So let's we can eliminate that directly. That means then we're left with these 3 options, these 4 options here. Okay. Now, if we're trying to find the least polar yet least polar yet still a polar covalent bond, oxygen can't be an option here because that would be a non-polar bond. So the question is ask about the least polar, and so that's going to be a non-polar bond completely. And so with that said, based on the 3 that are left over, the two elements that are closest to each other, the nitrogen oxide them would be then the least polar of the bonds. Okay, so we kind of go back to what we did in the previous example, previous problem, and use that to help. Okay, so there's our answer. Okay. All right, so let's continue on then, and let's see what else we have. Okay, let's take a look at number 3 here. Same thing, answer the question, and then we want to find this time the most polar without being ionic. So with that said, that's ionic. Can't use that one. This is non-polar. That can't be an option. So the 2 atoms that are furthest apart then would be silicon and oxygen here. That would be your most polar bond. Yep. All right, so with that said then, when the bond between the 2 atoms are polar, what we're going to see then is that we have the electrons, they will favor one side over the other, okay, setting up then a polarity difference in the bonds.